Let's explore the Python functools module. This module provides higher-order functions and operations on callable objects, allowing you to work with functions in more advanced and flexible ways. We will specifically focus on the reduce function, partial function, and the recursive decorator. The reduce function is used to apply a function of two arguments cumulatively to the items of a sequence, reducing the sequence to a single value. To use reduce, first import it from the functools module. Reduce applies the function to the first two items in the sequence, then to the result and the next item, and so on. This process continues until all items in the sequence have been processed, resulting in a single accumulated value. Reduce is useful for operations like calculating the sum or product of a list of numbers, finding the maximum value, or performing other types of aggregations. Here's an example of how to use reduce to sum all the numbers in a list. We define a list of numbers 1, 2, 3, 4, and 5. Then we use reduce with a lambda function to add the numbers together. The result, assigned to some result, is 15. Here's another example to find the maximum value in the list of numbers. We use reduce with a lambda function that returns the larger of the two values. The result, assigned to max value, is 5. Here are some advanced examples of how to use the reduce function. One common use case is flattening lists. This involves taking a nested list structure and turning it into a single list. To flatten a nested list, we import reduce from functools. Then we have the nested list containing lists of numbers. We use reduce with a lambda function to concatenate the lists together. The result, assigned to flattened, is a single list containing all the numbers. Another advanced use case is function composition. This involves combining multiple functions into a single function. To compose functions, import reduce from functools. Then we define a compose function that takes any number of functions as arguments. Inside the compose function, we use reduce with a lambda function to create a new function that applies the functions in sequence. Here's an example of how to use the compose function. We define two simple functions: double, which multiplies a number by 2, and increment, which adds 1 to a number. Then we use the compose function to create a new function called compose that applies both double and increment in sequence. When we call compose with the argument 5, it first increments 5 to get 6, then doubles 6 to get 12. The partial function is used to create a new function with some arguments of the original function pre-filled. This is useful when you want to create specialized versions of a function with specific parameter values already set. Partial creates a new function with fixed arguments, allowing for function reuse and specialization. It simplifies callbacks with specific parameters and helps implement function currying. Here's a diagram to illustrate how partial works. We start with an original function that takes arguments a, b, and c. We use partial to create a new function with the argument a pre-filled with the value 10. The new function now only requires the arguments b and c. Here's an example in code. We define an original function called power that takes a base and an exponent as arguments. Then we use partial to create specialized functions called square and cube that have the exponent pre-filled with the values 2 and 3, respectively. The square function calculates the square of a number, while the cube function calculates the cube of a number. Here's another example with multiple arguments. We define a function called greet that takes a greeting and a name as arguments. Then we use partial to create a new function called say hello that has the greeting pre-filled with the value hello. When we call say hello with the argument world, it returns the string hello world. The recursive decorator implements a least recently used, or LRU, cache for function results. This means that it stores the results of recent function calls so that they can be quickly retrieved if the same inputs are used again. This can significantly improve performance for expensive function calls that are repeated with the same arguments. Recursive caches function return values and avoids redundant calculations, making it perfect for optimizing recursive functions. It also has a configurable cache size with the max size parameter and can track cache statistics. Here's a diagram to illustrate how recursive works. When a function is called with certain arguments, the recursive checks if the result is already stored in the cache. If it is, the result is returned directly from the cache, saving computation time. If the result is not in the cache, the function is executed, and the result is stored in the cache for future use. Here's an example in code. We import recursive from functools in time. Then we define a recursive function called Fibonacci that calculates the nth Fibonacci number. We decorate the Fibonacci function with recursive with max size equal to 128. This tells recursive to store the results of the 128 most recent calls to the Fibonacci function. Without the cache, calculating Fibonacci of 30 would be very slow, but with the cache, it's very fast. We can also access cache statistics by calling the cache info method on the function. This returns a named tuple containing information about the number of hits, misses, max size, and current size of the cache. Finally, we can clear the cache if needed by calling the cache clear method on the function. Here are the key takeaways from this module. The reduce function applies a function cumulatively to sequence items, reducing them to a single value. Use cases include aggregating values like sum and product, flattening nested structures, and function composition. The partial function creates new functions with pre-filled arguments, enabling function specialization. Use cases include creating specialized functions, simplifying callbacks, and implementing function currying. The recursive decorator caches function results, improving performance for expensive calls. Use cases include optimizing recursive functions, memoizing expensive calculations, and API call caching. For further reading, refer to the Python documentation on functools. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.